All right, now we're going to get to the part 2 of our lab, and we're going to be showing you what you're actually going to measure. In part 1, we actually prep the sample, and however many samples you brought is how many you have to prep. And there should be at least 3 that you're prepping today. So this is the first one. Don't forget to label it. Usually a pencil works the best, but if all you have is a pen, that'll work too, but if it gets wet, it'll probably smudge. So anyway, we have this all ready to go. And as you can see, this soil has been basically dissolved in water, equal parts water. So what is it that we're going to measure? Well, let me show you. What you're going to need for this lab is, first of all, you get the advanced water quality sensor. Yeah, I know it's soil, but it actually measures the same things. There's 4 things it's going to measure for us. pH, the wet as well as dry. Also the conductivity, or the EC. That will tell us how much salt is actually in this soil sample, which is really important, especially in this area. And then on top of all of that, we also have temperature. So 2 kinds of pH, conductivity, and also temperature. But also we're going to take a look at, as I said before, the dry pH, and this is the pH sensors you'll need for that. For this lab to work, this is the heart and soul of what we're going to do today. This is, as I said before, is the advanced water quality sensor. We're going to put in our probes in each of these particular inputs, primarily so that we can get all that information into the computer, and we can obviously log it and then analyze this particular soil in terms of the conductivity, also the pH, as well as the temperature. So we have a lot of things going on here with this. So in order to make all this work, we first of all have to make sure we connect everything. So this is the sensor, this is the probe. This probe is called the conductivity sensor. It says so right on the probe. And you match it with whatever it's labeled here. And since the conductivity, it's labeled conductivity here, this is the EC reading, or the electric conductivity part of our sample. And then what we're also going to do is we're going to get the aquatic pH. It's this one right here. It says pH on it, but it's the blue, which reminds me of water, which means that's going to be the aquatic variety. So that goes right on this coax connector. And then the other thing is a stainless steel temperature probe, and that will go right over here on the side where it says temperature. Now it's time to measure our sample. You'll notice that our sensor right here is kind of all by itself. It also needs another piece to the puzzle, and that's a data logger. Now here is one of the data loggers that we could use. It happens to be a tablet variety. We're not going to use that in this particular lab, but it's one of the ones that we probably will use on other labs. So what we're going to use is the handheld version. It's a little bit older version, but it works just as well, and many of you already know how to use this. So how this is going to work is you're going to put this sensor into one of these inputs, the input port, and then of course you turn it on, and then it will give you the responses based on what it comes in contact with in the soil. So how this works is we're going to put that in there, and then we're going to take this conductivity sensor, I'm going to place it in there, and I'd stir it around a little bit, and then after 15 seconds, then you probably should go ahead and take your measurement. Notice I'm holding it so it's kind of in the middle of the solution. I don't let it drop all the way to the bottom while I'm taking the reading. So I'm going to take this reading, and it says it's 89 decisiemens, which means it's a little bit under 100, and it's still of good quality in terms of the amount of salts that are in it. It's not at a area that we really need to be concerned with at this particular point in time. So that one's done. Set that off to the side, and then I'm going to use the pH probe. Now, when you use this, please be very careful of this little bulb. It breaks fairly easily, and each one of these is about $50–$60. And obviously we want to make them last as long as we can. Again, I stir it around a little bit. I let it settle. 7.1. So it's slightly alkali, which isn't unusual for this area. So that's what you're going to be measuring. Of course, you can do the temperature probe and you can do the other stuff dry. But I just wanted to let you know this is the setup as well, and as well as those are the probes that we're going to be using. So when you get done with this, then you're going to upload all of this data that's in this data logger into the computer. I'll see you back in the lab. Thanks.